Hello, this is Jim Sutton with Stone Tablet Innovations. Today we're going to work on video blog number 11, which is getting a little bit more interesting now because we're going to do how to display text and scroll on an OLED display, again using the Espressif ESP32 chip. So we're going to do this in 3 steps. The first being we're going to do the hardware setup, how to, where to buy the equipment from and how to wire it. Then we're going to do something called discover the OLED device on the OLED bus. And then we're going to run a demo code and look at some of the commands that are available. So as far as the hardware goes, again, this is a repeat a little bit of the earlier hardware setup because it's the same dev kit C we've been working with all along. What is new is we have a 0.96 inch white I2C serial OLED display, which we're going to show a picture of in a minute. It's available in different colors. The white is, I guess you're going to just get monochrome out of it, but I think it looks sort of nice. This is not that expensive a display. It's probably about $7, available on Amazon. Again, to do the power and programming, make sure you have a cable that has enough copper in it to really be able to run the power as well as the signal lines. You need a breadboard to do this, and I think it's really nice to have some breadboard jumpers to wire it up. So let's take a look at how it gets wired up. So it's pretty simple. We only have 4 wires that we really have to worry about to connect the display with the ESP32. Down here it describes it. One is a SDA is the data line and SCL is the clock line. To make the data move. It's using the 3.3 volts supplied by the Espressif ESP32 chip, and obviously you want to ground it. So this is what it looks like on a breadboard with a couple of jumpers, and you can see where I've got the USB cable plugged in. So now we've got our hardware set up, so let's move on to step 2, which is discovering the device. For this year, we're going to use, for this step, we're going to use a program that is provided for free by Espressif called I2C Tools. It's in the same examples directory. We'll show installing that in a minute. But the key thing we're going to look for is this I2C detect, because it's going to scan the I2C bus for devices and output a table with the list of detected devices. And this is nice because my I2C chip here didn't come with much documentation at all. So I didn't know, what its exact address was. So we'll show you that in a second. So to do this, we're going to do the same process we've been doing in the other tutorials, and we're going to do these quickly. But you can go back to some of the earlier ones if you need a little more detailed thing. We're going to build a directory. We're going to connect. We're going to configure, build, flash, and monitor. All right. So we're going to copy one of those examples. So let's go in the ESP IDF examples. And we want to go into peripherals, I2C, and I2C self-tools. And let's just see what's in that a minute. Yep, so there's the main and all the files that we'll actually need for building it. So I'm going to go ahead and copy it. And let's go back into ESP and STI projects. We'll paste it in. And consistent with what I've been doing here, we'll do 07 underscore I2C tools. It's just so much easier in Windows to do it that way. Now we can start the build process with the command line. We'll go ahead and build this project. First, we have to get into the project directory. So we'll do cd sti projects and see what we have in there. There's the 07, so we'll change directory 07 underscore I2C underscore tools. And now we can set the target. So with the set target command is ESP32. And it'll take just a minute while we set the target, and it builds the So now that this is fully configured, we can do the final build in Flash. So idf.python/port is com3, and oops, that won't work. /port com3/pod 115/200 and Flash. And we'll do monitor 2. Okay, well, we'll now that it's building it, I'm just going to pause it for a second and turn the recording on once it's finished making and building. So we're now, I missed it a little bit where we finished building it. Now we're writing it to the ESP chip. It's almost done. And we're ready to try a command through this little monitor program. So I'm going to do this I2C detect, and which should scan for devices on the network. Oh, there it found it. Its address is 3C, so everything is working, and we've been successful with discovering the OLED device. So now we're ready to enter our third task, which is running the demo program for the OLED display, which actually puts text on, so it's a little more fun to look at than just discovering. There are many demo programs available for the Arduino with the OLED display, but these are in that sketch format, which I don't like. I want to stick with all C code, so we're not putting any sketches in. So we'll either find a library or build our own. So I went looking, and a fellow named Yanbi from Japan has sample code on GitHub. And it's pretty good, but it has a bug in clearing the display. It has some unusual parameters for the scrolling part of the demo, and some names of the variables are confusing. He also has some multiple tasks rather than just one task for the simple demo that we want to do. And finally, he's using Eclipse as the IDE, so it's not going to be able to be built the same way we normally do. So what I did is I made a demo program. I adapted it from Yanbi and made it available on GitHub. He did a Apache license, and I'm continuing with the Apache license, which you can read the details, but gives a lot of flexibility in how you could use it. The main differences are the improved initialization and explanation in the code. I removed the tasks, and we can build it with just the IDF tools. So you can download it from GitHub, and I have the address in the text that goes along with the YouTube video. But let's go ahead and clone it and build and flash this program. So now we can look at the program actually working. I think you just saw it pop up. It starts as dark, and then it flashes up with line 1 being fixed. Line 2 is blank. Line 3 has OLED working. Now, before we look at the programs a little bit, there are 3 good references you should know about if you want to do more work on this. The Solomon technical reference, there's a link in the README. You may just want to Google it and find it. Solomon doesn't seem to give this out on their website, but a lot of people seem to have picked it up and published it, so it shouldn't be too hard to get. The I2C technical reference goes into more detail on how the bus actually works, and you may need that if you have any trouble. Finally, the Espressif I2C API package has some good documentation on how to initialize the driver and work with the various pieces. I wanted to spend just a few minutes looking at the files that make this display work. Right now we're going to look at the main.c and as usual with this IDE, they want to have here's the project, here's the main, and the main files here, and there's the build directory. So we're going to look at the main.c. In a minute, we'll take a look at the font file and the OLED header file. So at the top, we have our standard legal information, and I want to credit Jan B here because I really adapted his code to make it better for this demo. And so just looking, so we have some includes here, and these are very typical of what you would see. Again, here are the 2 header files we're going to look at in a minute, where we're including them. Here is where we're setting the serial data line and serial clock line that we showed earlier. So the first thing we're going to do actually is we need to initialize the I2C driver, and that's all Espressif code, and this 100,000 is as fast as we ever run that bus. Okay, so once we have that initialized, we can do the this SSD1306 installation initialization, and we do this, and I put again, you need to, if you want to get into this in more detail, you have to look at that documentation I referenced. But essentially, you write a command, and then you tell it you're going to send additional commands, not data. And I do some initialization here of setting the addressing mode, which is well described in the reference material. And when it's all done, when you put true here, it's really asking to send an acknowledgement for every command you send. But this is where I'll gather any errors. And with most of this stuff, if everything works well, it says ESP OK is what it sends back. So you can see if it configured successfully. And then we do a display clear. Now, there was kind of a problem in Jan B's posting on GitHub. It's pretty easy to fix with one line to put zeros in it. And I have a slightly different addressing thing where I like to be very clear about whether we're sending commands. We're going to first send the commands to set up the row, and then we're going to write the data. And you can look into this a little bit more if you want. Then we get into the scroll sections. And in this case, I wanted to be able to demo 3 different things. I wanted at least one row to be static and not moving. I wanted to show one a couple of rows that were moving, scrolling horizontally. It turns out that 2 of these are blank, but so you only really see 1 in the demo. And then 4 per 7 are going to go both horizontally and vertically. And you can look through the code a little bit to figure out a little bit more how that works. This next thing, OLED Display text, is called from the main, and I probably have to jump there to have it make any sense. So the app main is what you always use as the main routine for these ESP32s. So this is what we just looked at, the I2C master init, the SSD 1306 init, to clear the display. Then we wanted to display a string of characters. And the first line is going to be stone tablet. The /n is a signal that we want to jump to the next line. So that's line 1, really called row 0 on the display. And then it's going to write OLED working, which is going to scroll. And then we're going to jump to the bottom of the screen and just put an X so we can see it moving up and down the screen. So we call display text, and then we set the scroll parameters. And that's what we need to do with the main routine. Line 4 is blank, but it's also scrolling. And we just looked at the main. I want to take an even quicker look at this header file. And in this, there are a bunch of numbers are given a name to make it easier to find them. Again, you need to read the technical reference if you want to get why, exactly what these commands are doing. But they're all stored in OLED.SSD1306H. The last thing I want to look at is the font file. And Yanbi explains how he took a very old IBM font, which was configured to be a series of 1s and 0s, kind of scrolling horizontally, and he made it into a vertical scroll, which works better with this display. And all that information is in here. But basically, when you look for a letter, let's say you're looking for K, it's going to pull out this series of 1s and 0s to help it display the 8x8 matrix on the OLED display. So those were the 2 important things I wanted to show. Again, we had to add in some CMake lists because Yanbi didn't do those. They're very simple, and we're in there. So that's what I wanted to show from the code. Remaining lines, you see that X scrolls. So we're nearing the end of this longer video. We did the hardware setup, showed how to do what equipment to buy and how to wire it. We discovered the OLED device's address, and we got a demo program from GitHub and ran it to show it actually working, and looked at some of the commands that are available. So thank you for listening to this, and don't hesitate to subscribe or listen to some more. Thanks again. Up from the bottom, and I think you'll have fun seeing it do all these features. And it was meant just to show the different scrolling capabilities and writing. We're going to go ahead and get the code from GitHub, but first of all, let's make sure before we clone it we're in the right directory, and we see the other projects we've done. So I'm going to now do git clone, and I'm going to paste the name of the file, and so it's doing that. I'm going to paste that that address in the text, so you can find it easily. Let's see what So as well. Oh, I see what happened. Change directory. OLED -128 x64 I2C driver demo. All right, let's see what's in there, and let's see if it has a Git, so we can just do Git status. Okay, everything's working, tree is clean, and everything's ready to go. So we can do our normal idf.python, and we're going to go set target ESP32. So it's executing the this action. I'm going to pause the video here for just a second until it finishes, so to save you guys some time. All right, it's done the initial piece of make, so we're going to go ahead and do menu config and make sure the size is correct. We'll go to the serial flasher configuration and change that to 4, because that's the size of the size of the dev kit C. So I'm going to save it. So our configuration is saved, so I can escape and then escape, and I'm done with that. Port COM3, this is all old stuff. So I'm going to go ahead and pause it again while possibly, making a video here, so you don't have to watch it. Spend 2 minutes building it all. We're back because it's now starting to generate the binary, meaning it's almost done, and it takes just a couple minutes. But when you're waiting on a YouTube video, it takes forever. Okay, so it's written it to the serial port. And success, it's loaded it and running it. We'll go ahead and show on the next slide what the screen looks like.